Welcome back, Intermediate Algebra students, for our second day of Section 4.4, where we continue to look at linear inequalities. Once again, this is Ms. Leminski. As promised in yesterday's lesson, I said we would start today with a warm-up where we look at one more word problem, or a real-world problem, since we didn't have time to do more than one yesterday. So in this case, the Science Club sells t-shirts and keychains. So we're talking about two separate things, which will be important to raise money. Each t-shirt sells for $10 and each keychain sells for $2. The Science Club has a goal of making at least $500. How many t-shirts and keychains could they sell to meet their goal? Okay, so I underlined two key words. In this case, when it says let X represent and Y represent, I'm going to identify t-shirts as X and keychains as Y. So my X is going to be t-shirts and my Y is going to be keychains. You guys want to make sure you identify those variables first. At the beginning of the chapter, Ms. Browningham did a nice job of showing you the Freyer model to do word problems. Here we're kind of extending and following the same thought process, but instead we're just kind of doing it in a list. Okay, now it says I want to write a linear inequality. The next sentence, or two sentences, starts talking about how much each item costs and how much they ultimately want to be able to make. So in order to write that, if each t-shirt is $10, I would write that as 10 times X because I get 10 for every t-shirt I sell. I also get $2 for every keychain. So anytime it's also, then it's and or plus, and then 2Y. Now I want to make at least $500. Okay, so understanding this language is important when we're doing inequalities. My 500 goes over here. Before this section, we would put an equal sign because we would have said I want to make $500. But if I want to make at least $500, I would be okay making 500. So I could just make that, but obviously I would also be okay making more than that. Okay, so the amount I sell is on the left-hand side here. I'm okay with that being 500, but I'm also okay with it being greater than. So greater than or equal to 500. So that's the linear inequality that I came up with. Now it says graph it. Does it make sense to have negative values? So when we go to graph, always ask yourself this question, because as soon as you start graphing in a grid, you want to see if there's any restrictions to the domain and range. If I'm selling things, I can't have negatives. So when I graph on this grid over here, it's actually going to start at 0 for both my x's and my y's. So really, I'm only graphing in the first quadrant, okay? Now, in order to graph this is currently in standard form. So we've been talking about how we can convert it to slope-intercept. I would subtract 10x. I get 2y is greater than or equal to, I like to put that negative 10x in front, just because then it's mx plus b. And then I divide all three pieces by 2. That's the way I talk about it, so I don't make mistakes. Negative 10 divided by 2 is negative 5x. 500 divided by 2 is 250. So when I graph this, I always want to find the y-intercept, which in this case is that 250 on the end. So that means that I have to have a point way up at 250. So this is my y-axis, which is going to be keychains. I'm going to decide to count every 2 boxes as 100 then. Okay, so you kind of get to pick your scale. So when you're sketching this in your notebook, you can count by 100s going up. And I would go with a point at 250. That's the y-intercept. Now my slope, which is what we oftentimes talk about next, that's negative 5, which is negative 5 over 1. The problem is since I counted by 100s, to go down 5 over 1 is going to be kind of hard to see. So yesterday we talked about you can always find another point. The other easy point to find would be the x-intercept, because that's when y equals 0. So even though this is an inequality, I would take it and write it as an equation real quick. Subtract 250 from both sides and divide by negative 5. I actually get x equals 50. Okay, so down here, and I moved my graph down a little far. So this is t-shirts down here. Sorry if you can't really see that. But that only needs to go up by 50, or up to 50. So I'm actually going to count every 2 boxes as 10 on the x-axis. 30, 40, 50. Okay, so that puts a point right here. I need 2 points to graph a line, so I'm going to connect those. But before I graph it, again, when we graph an inequality, so this reviews what we talked about. We plot 2 points, which I did. Now I have to decide if it's solid or dotted. My inequality symbol was greater than or equal to. Because of the or equal to, it's going to be solid, so a solid line. And then last but not least, when graphing inequalities, it's not just the line, but it's a whole region of the graph. So I need to use my test point. I'm going to write the work down here. We talked about how 0, 0 is always my favorite test point. So I had y is greater than or equal to negative 5x plus 250. Because 0, 0 is not on the line, I am in fact okay testing it. Makes this part go away. So I ask myself, is 0 greater than or equal to 250? And no, it for sure is not. So if it's not, that means that point I tested down here is not a solution, which means selling 0 t-shirts and 0 keychains does not make me greater than or equal to 500, which definitely makes sense. So if this isn't a point, that means this isn't a solution, this isn't a solution, this, anything down here is not a solution. But by default, then everything on the other side of the line is a solution, so everything up here. Okay, so when we're just graphing, that's a review of graphing inequalities. That's what we did most of. But then understanding what your graph means, explaining your solution, is the key. What this means is I can sell any combination of t-shirts and keychains that falls up in the shaded region, or that falls on the line since the line is solid. So for example, if I sell 0 t-shirts and 250 keychains, that meets my goal of raising at least $500 because it falls on the line and the line is solid. If I sell 50 t-shirts and 0 keychains, I meet my goal of making at least $500. But I can also sell any combination I find up here. So for example, I could sell 40 t-shirts and 300 keychains. That would be a solution. I could sell 30 t-shirts and 200 keychains. That would work. Any point or combination I find up here would help me make my goal of making at least $500. Okay, so that was a longer warm-up, but again, we needed another example of it. Today's lesson, we are going to switch the way we look at this. Yesterday, we were given an inequality and we learned how to graph it. Today, we're given the graph and we are going to write an inequality from that graph. Once again, we have 4 steps in order to do this. Step 1 is ask yourself from the graph, what is the y-intercept? So I look at the graph. So now we're going to do this. So get the sketch of this graph in your notes. And again, I look at the y-axis and I see that this point down here is my y-intercept, which is at -1, -2, -3. So I'm going to keep track over here of what I'm doing. My y-intercept in this graph is -3. Once I know that, I'm going to ask myself, what is the slope? In order to find the slope, I usually start from that y-intercept because it's a nice, neat point. Then I find the closest point to it that is at a nice, neat intersection of the grid. So I have to find, so this is right on the intersection of a grid box. Make sure you do that. It's not always right next to it. Okay? So when I go to find the slope, I find 2 exact points on the graph, and then I count my rise over run. In this case, I rise 1 and I run 1 to get from one point to the next. So I rise 1, run 1, which means my slope is 1. Once I'm here, I kind of process what this means. If we're thinking mx plus b, and we're just doing the right-hand side of the inequality right now, my slope is 1, so that's a 1x, and my b is -3, so -3. So that's the right side, and I know the left side is y. But the problem is I can't just say y equals 1x minus 3. I have to now figure out that inequality symbol. The third question is the easier one, and that is the line solid or dotted? And in this case, it's solid. So I just ask myself that question, which means that my inequality symbol has to be underlined. So it's either going to be a greater than or equal to or a less than or equal to. So I need to decide between these. I don't necessarily always write that down, but that's what it's. So when I ask myself solid or dotted, I decide or if it's underlined or not. Step 4 is the hardest. Step 4 is where we decide which way should the inequality face. And you're probably going to want to write some extra notes for yourself under that. And on the note sheet at the end, I do put a couple extra tips. But right now, I just want to show you what we talk about. Okay, so in order to do that, we are still going to use a point to decide. Okay, and you can maybe write this under here. So I, in this case, am still going to use that 0, 0. It's kind of a test, but not really. So I'm going to use 0, 0. But here's the key. In this case, I have to ask myself, is 0, 0 an actual solution? And because it's in the shaded region, I need to know that yes, it is. So once I go to figure out my inequality, I say, okay, I know y is over here. I know 1x minus 3 is here. My job is to figure out which direction this inequality faces. Okay, so I'm going to go with some highlighting down there. Well, so I'm going to plug in the 0, 0. So 0, 1 times 0 minus 3, 0, 0 minus 3. And I compare 0 to negative 3. Once I simplify, and again, I keep leaving that blank, because my job now is to ask myself how this would be true. How do I make it yes? And that's why it's important I knew it was yes in the beginning. So how do I make this yes? Okay, and the answer for me, let me go back and highlight that though, so this is going to answer this question. The answer for that is, to make this a true statement or yes, 0 is greater than negative 3, right? Which means my symbol needs to face this way. Now I combine that with what we talked about up here. I also need to underline. So in order to make that true, 0 has to be greater than or equal to negative 3. That is a true statement, which means that that is the direction my symbol needs to face. I put that back there, and here is my answer. Y is greater than or equal to 1x minus 3, or just y is greater than or equal to x minus 3. So again, step 4, you're kind of using the idea of the test point, but you have to decide, is that a solution, yes or no, and then make it match in the end. Let's do another example. What inequality does the graph represent? I look at my graph, and I remember step 1 is to find the y-intercept. Well, in this case, the y-intercept is actually 0. Next, I find my slope. So I take that point, and now we'll see, like this next box over, it's not at a nice intersection point, not at a nice intersection point. This point right here is where I see the next nice intersection point. So to get from point 1 to point 2, I rise 1, so rise is 1, and I run 1, 2, 3, positive 3. So my slope is actually going to be 1/3, which means the mx plus b part is 1/3 x plus 0. We do not usually write the plus 0 on the end, so we'll get rid of that as we go. Step 3 was to decide if it's solid or dotted. This one's dotted. All that means is once I decide the direction, it's not going to be underlined. It's going to be one of those two. And now step 4 is to figure out the direction using a point. Here's the problem. I always like to use 0, 0, but this time 0, 0 falls on that line. So I just need to pick any other point I want. I can pick any point in this entire grid that's not on that dotted line. Having said that, for me, I oftentimes like to pick a point in the shaded region. So for no specific reason, I chose to use the point 0, negative 2. Again, you could have used this point, you could use this point, you could use this point, you could use this point, you could have used points up here too. If you used it in the non-shaded region, you would figure out how to make it no, but because this is a solution, I need to make it yes when I plug it in. All right, so again, we're taking y compared to 1/3 x, that's this. I plug in -2 for my y, 1/3, plug in 0 for my x, right? That's my xy point. So I need to come, -2 to 0. And in order to do that, once again, and I like to highlight this part, all the way along, what I'm trying to do is I need to decide what direction this needs to face to make it yes. Because I decided it's yes. Again, if I had picked a point up in this region, I would need to make it no. But I need to make this a true statement. -2 is less than 0. So because -2 is less than 0, my inequality goes that way. Again, I decided up here because it's dotted, I won't underline. So it's just y is less than 1/3 x. Or y is less than 1/3 x plus 0. Okay, go ahead and pause the video and try this one quickly. And then unpause it and see how you did. I'm not going to show as much, but my y-intercept was 1. My slope was -2 over 1, which was -2. So you should have had -2x plus 1. It is solid. So you're either going to have greater than or equal to or less than or equal to. I am allowed to use my point 0, 0. And 0, 0 is a solution. So I'm looking to make it yes. So I take y compared to -2x plus 1. That's going to be my answer. I'm just figuring out the symbol in between. 0, -2 times 0 plus 1. I need to make 0 compared to 1 a true statement because it's yes. So 0 is less than or equal to, again, is or equal to because of this. 0 is less than or equal to 1. That makes it yes, which is what I needed because that matches here. And now I take that symbol and I put it in my inequality. Y is less than or equal to -2x plus 1. All right, one last example. Does this inequality represent the graph? Okay, it's 3y. It's greater than or equal to 2x minus 2. And so really we just go through and simplify everything. So I get y is greater than or equal to 2/3 x minus 2/3. In this case, my y-intercept is -2/3. That looks about right. My slope is 2 over 3, which actually going up 2 over 1, 2, 3, that looks about right. So these are okay. But then remember, we would do solid or dotted. In this case, it's dotted, which means that it should be a less than or greater than. And right now I recognize that actually it was greater than or equal to. So does it explain the graph? No, because dotted. They should have used just this or this. Okay, so that was just kind of an extra example to process through. All right, that is the end of our section. You can pause here if you want to see kind of a summary of what we did this chapter in graphing. But here's your 4.4b note sheet. You can pause this, get it down. Otherwise, it should also be in your Schoology folder. Your job now is to go to your 4.4b Pearson practice. Thanks.